Good afternoon, everybody. Welcome to this webinar. I've got to tell you, it's the first time we've at the Flight Safety Committee here we've done a webinar like this, and to be honest, I didn't think anybody would turn up, but we've got nearly 30 already. So thank you so much for coming. I hope you do find it useful. We're going to be. My name's Rob Holliday. Some of you don't know me, and I'm with the Flight Safety Committee. We'll be talking about ICAO's document 1059 on safety intelligence, which they released last year. And I hope it's useful. I think we don't have a panel for this, but looking at the audience, we've got a lot of experts there, so you can all be my panel when we get a discussion going at the end, perhaps. I've got some talking to do, probably be just over an hour, and then there'll be time for some questions and discussion. If you, when we get to the end there, you could always put your hand up to ask a question. I can unmute you, or you could put it in the chat as well. So without further ado, I will share my screen. Right, so there we go. ICAO document 1059 Safety Intelligence Manual. And when I read it, it's written very much like a lot of ICAO documents. It's a tough read, to be honest with you. And it reads at the highest possible level. If you were going to do this and you had unlimited resources, everything's in there. But it does also use that lovely word scalable. So it does reference that this can be done at scale according to the size of your organization, the resources you've got. So we'll reference that bit as we go through. I've got the list of chapters here. Some are more interesting than others. So chapter 1 defines safety intelligence. We'll look at that. And then the difference between safety data and safety information. Chapter 3 is about processing. Chapter 4 is about safety data collection. 5 talks about governance, which is important. We won't spend too much time on that. And then 6 and 7, which is about the analysis and then the use of that analysis for decision making. That's pretty important. Chapter 8 talks about data sharing. It really goes into how to set one up, to be honest. Again, not going to spend too much time on that, but we will cover it. And then Appendix A is really the code of conduct on the sharing and governance of safety information, which again is more for reference than anything else. The manual's kind of aimed at state safety programs as well as safety management systems. We'll be focusing more on the safety management side of this, as you might use it in an operation. So chapter 1, safety intelligence. What is safety intelligence? Well, basically it's making something useful out of the information that you've got. And obviously for me, people are the most important part of that, because even if you've got a bunch of numbers, it's the people that were there at the time that can tell you what happened, why it happened, and give you all of that important contextual information. Process can help, technology can help, but actually I think the people's input is the most important part. And that can lead on then to make a more informed decision. And we'll talk a bit about the data-driven decision-making and informed data-informed decision-making later on. And I think if you get the proper story and the full picture and you understand it, then that's going to help enhance your safety culture. And also with that deeper understanding, you could start to see perhaps things that might be coming down the track at you. So they talk about a pyramid with the base being collecting the data. And I'm sure if you're working for an operator, you've got lots of processes for collecting different forms of safety data around your operation. And then it's around classifying it, analyzing it, and adding in all that additional information so that it makes sense if it's going to lead to some sort of action that is there at the top of the pyramid. And the most important thing about that is the context questions like who, what, why, and where. And that is super, super important. And there's a little example of why context is important.
Is the idea that situations are invisible. We see people, we see what they do, but we don't often see the circumstance. We don't see the situational pressures. For example, imagine a man walking through heavy wind. There's a clear situational explanation for why he's walking so weird. It's the wind, but we can't see the wind necessarily. And in the same way, when people are actually influenced by the situations that they're in, we have trouble seeing that influence.
So that's why context is so important to data interpretation. I'm going to give you a little test now. So this is the Griggs and Cox selection task. And the rule is, if a person is drinking beer, then he or she must be 18 or over. And your task is to decide which two cards must be turned over to check if the rule is true or false. Give you a little minute to think about that. So the rule is, if a person is drinking beer, he or she must be 18 or over. So which ones would you turn over to check that the rule is true or false? Okay. So the correct answer is the beer card and the 17 card, and that's because beer is part of the rule, and so if you turn it over, you can check their age. And 17 is under 18, so you need to make sure that they're not drinking beer to ensure that the rule has been applied. If they're drinking Coke, it's fine, and if they're 19, it's fine because they're over 18. So that's a relatively straightforward test. What about if you do it this way? The rule is, if a card has a vowel on the other side, then it has an even number on the other side. So, sorry, if a card has a vowel on one side, then it has an even number on the other side. So which two cards in this case would you turn over to check if the rule is true or false? Just give you a minute. Right. The answer to this one is A, the vowel, and 7, the odd number. And the reason is that the rule says a vowel on one side. So A is a vowel on one side. So if you turn it over, you can check to see if it's got an even number. B is a consonant, so it doesn't matter. 4 is an even number, so it doesn't matter. Anything can be on the other side of that. And 7 is an odd number, so you need to make sure that there's no vowel on the other side of that. So it's A and 7. Now, I know the group is too big to see who got what, but I'm guessing that the first test with the beer in the 18 age was most people got that right and fewer people got this one right. And the reason for that is that the first test had context. It had a social context. So it was much easier to determine what you needed to do in order to check if that rule had been properly applied. And that the idea of this is really to demonstrate that when you just have data without context, it's much more difficult to figure out what's going on. So I hope that kind of made that point. Moving on to back onto the ICAO document then, the safety intelligence cycle, probably something you probably have more or less this in all of your organizations, where you decide what you need, you collect the data, you look at it, process it, analyze it, and then you report it in visualizations and so on. And then based on that, you can make decisions, you can communicate those decisions, and then you can check to make sure that that's been effective. So it's probably not an unfamiliar cycle to you all. And of course, I would also assume that that would fit or does fit very nicely into your safety management system, where you're looking for hazards and risks, you're analyzing them, and you're setting up objectives, and then you're monitoring how that works and how your performance goes with a continuous feedback loop. So I don't think that's anything particularly new. And likewise with this is talking about establishing this from scratch. So if you're going to collect all of that contextual data, you're going to need to be cooperating with other departments and possibly other external entities in order to gather the information that you need. Expert knowledge is super important. Having that knowledge of people who do the job, who work in that particular area to give you those insights is also very important. And then once you've gathered all that data, you've got to take care of it. And there has to be some governance and rules around how you use it, who sees it, and how long you keep it, and so on. And all of that, those processes help to build a level of literacy within your staff. And because we are all, let's face it, swamped with data these days, and understanding how to use it effectively is becoming quite a skill. So the organizational models that ICAO quote is that they actually talk about a centralized model, which when they describe it sounds like the CIA, but you could do that, or probably in an operator, it's probably a bit more shared between different areas of the operation, perhaps the safety department bringing that collaboration of all those areas together, or it could be completely decentralized where each department does their own thing. But that's probably, as I say, they're going to need to be talking to each other because they are going to need data from each other in order to understand their own events. And they do also acknowledge in the document that you could outsource this to a third-party company to do it for you as well. Yeah, critical success for me, the top, I know you need resources, which is in the middle. You're going to obviously need resources, but you need leadership to back you, and you need a culture. You need a culture of continuous improvement, of an inquisitive culture, a learning culture, one that's prepared to say, what went on here? Let's try and understand it. What can we learn from it? Do we need to do anything to be able to improve? So for me, the top and the bottom are super important. And actually, you can have commitment and you can have culture without too many resources, but you're gonna also need to have some time and money to do it too. So moving on to chapter 2, which is safety data versus safety information, and they talk about, this probably makes sense, safety data just being the numbers, the raw data, and safety information being that those numbers and information has been enhanced now because it's been processed and organized and additional data sources have been added to it. Now it makes more sense in terms of supporting any decisions that you have to make. And then they talk about quantitative versus qualitative data. So along those lines, quantitative is numerical data. Usually that's fairly easy to capture. The qualitative data comes from the safety experts, the people with the domain expertise that can give you that additional insight into to complement what those numbers really mean. You could collect it from a variety of sources, as we've already mentioned, both internal and external. And then there's contextual which is non-safety data on its own, like the weather, the environment, the operational metrics, and so on, to help understand the risk. And all of that is integrated in order to give you what they call safety intelligence. And by collecting all that data, you can start to build a portfolio. You can build relationships with those organizations. You might even collect it through automation, through APIs. And all of that's going to feed into your system. But it's not just about more data. It's about collecting the right data. So you kind of have to decide which is useful and which is not as part of this process. I'm sure you're all familiar with mandatory reporting schemes, as well as your own internal voluntary schemes, and the necessary trust and protection that goes with that, and the culture that you need. The manual also talks about manual versus automated data, and they kind of say that automated data is much more reliable and manual data is prone to subjectivity, unless I would say that both have those vulnerabilities. Automatic data can be wrong too. Manual data, yep, sure, we're talking about human reports, human perspectives, an element of subjectivity, and sometimes our recall is colored as well. But automated data is not always perfect. So I would add to what they say and say that you should also question automated data as well as manually collected data. You should have that mindset to say I need to verify this whatever the source is. And then of course there are coding, taxonomies, and mapping. And of course you do need to classify your data because it's going probably into some kind of database with lots of other data, and when you need to pull it out, it needs to have some kind of coding on it. But of course, whenever you put something in a box, there's always something that falls outside that box, like this poor little duck-billed platypus, which was discovered at the end of the 18th century. And at that time, scientists had three classifications. You were either a mammal, a bird, or a reptile. And then somebody discovered this thing, this animal that laid eggs, suckled its young, and had venomous claws. So it had characteristics of all three. And so it didn't fit into their classification. And that will happen to you sometimes. You have to be mindful of the fact that classifications are very useful, but they can also sometimes have limitations, and things can fall outside of the box sometimes. So, chapter 3, safety data processing. Data is not always perfect when it comes, and it could be inaccurate. It could be in different formats, and it needs to be cleaned up. It also needs to be validated and verified. And then if you're using multiple data sets, which is the general idea of getting to a point of safety intelligence, it's going to need to be integrated with other data sets and fused. Now, depends on what you've got available. Maybe you're just using a spreadsheet because you're a small operator. Maybe that simplifies it in some ways. Perhaps you've got a database. Hopefully your database can take different types of data. So I know that IATA Global Aviation Data Management System use Snowflake, which is a cloud-based data system that can accept unstructured and semi-structured data. So rather than being in the standard structured format that traditional databases have, Snowflake can take more or less everything and fuse it together. So if you're lucky enough to be able to afford to do that, then that's probably one of the top level ways of doing it. But you could also do it, as I said, down at sort of spreadsheet level. In chapter 4, they talk about a safety data collection and processing system. Again, scalable. I mean, it could be that it's all done in Word documents and spreadsheets, or you could have a really fancy database that allows you to, and business intelligence tool attached to it that allows you to feed in all these different data sources and fuse them together and compare them and correlate them and so on. But they do make the point that this is not just a piece of software. It's a joining together of processes so that you can collate all of that data. It sounds complicated, but it doesn't need to be. What it needs to be able to do is do the job that you want it to do. And so that's you need the flow of data, and then extract, transform, load is a sort of standard terminology for sorting out the data before you put it in. Again, you're going to need some rules around the data quality, access controls, and so on. And then it will need to be scalable so that it can accept more or less data as you go along. Data governance and management of safety data is chapter 5. You will need this. You probably, depending on your size of your organization, you may need to talk to legal, the IT department. The union might be involved in the way that you look after your data. I know they're particularly interested in how flight data is managed and protected. Code confidential is a bit of a subjective word, but when people report a safety issue, that report is confidential. Usually that means the generally accepted interpretation of what confidential means is it goes to the safety department and they decide who needs to see it in order to help look into it and investigate it. And flight data, for example, is completely de-identified. So all of those factors will need to be built in. And of course, if you're going to be collecting all this data, you want people to trust that you're doing the right thing with it. So yeah, all of that needs to be defined. Part of that governance is to ensure that you've got good quality data. Metadata management is important. Metadata is data about the data. So that's sort of the classifications you put it to. Excuse me, they talk about a structured implementation approach. I think that's probably true for the whole thing. If you don't have this, or you only have part of it, and you want to start implementing it, a structured implementation approach is good, and it's also something I would tend to do it and then write it up in the book, because they do talk about documenting all of this. I wouldn't write the book first. I tend to find out what works and how you're going to do things, and then document it after that. So now we're getting on to the interesting bit, which is safety data and safety information. So transforming raw data into meaningful intelligence using statistical and analytical techniques. So this will what you're obviously looking for trends, you're looking for patterns, you're looking for correlations, you're looking for upstream factors that contributed to whatever it is that's happened. And for that, you're going to need to integrate multiple data sources in order to get to that. That's data, that information that's going to be useful to you. This is the little graph from the book there, and they go from having a descriptive analysis at the bottom, which just tells you kind of what happened, being able to go all the way up to diagnose it, enable you to be predictive as to whether or not this could happen again, and then even being able to understand what you might have to do about it. So that's how they described the evolution of the process of analyzing the data. So integrating it, yeah, it's going to have to be integrated with contextual data. We've already talked about that. And that could be by using, it could be technology, or it could be subject matter experts. And then ultimately that data will allow you to make some changes. I've put an example here is, imagine that you've got some data that you're at a particular airport, you're seeing a lot of go-arounds because the aircraft is catching up the airplane in front. And you look at the flight data again, so you're adding in some contextual data, and the aircraft appears to be complying totally with air traffic speed controls, which is usually to around 4 miles. So that doesn't really explain why it's happening. And then you look at the weather and you see that actually it tends only to happen on windy days. And then you look at you talk to the flight ops, and they tell you about this airplane has a thing called a minimum ground speed function. So on those windy days, when they stop the speed control at 4 miles and set the approach speed, the aircraft has a built-in function that the computer will maintain a minimum ground speed, which means its airspeed will once the speed control is released, the airspeed will be higher than the final VREF. And so what's happening is the technology on the airplane, which is there for a good reason, is meaning that if they're behind an aircraft that doesn't have a minimum ground speed function, the likelihood is that they're going to catch up that aeroplane. And so by adding all of that contextual data in, with looking at automated data from flight data, talking to the subject matter experts, looking at the non-safety data such as the weather, you're able to build a picture and understand why these catch-up go-arounds are occurring. And now you can go and talk to air traffic control about whether they can accommodate this and understand why it's happening. And you can talk to flight ops about whether there's anything they can do to help with it as well. So that's just an example of how all that contextual data can help you to understand why a particular issue is happening. This is a video about having contextual data, and it's a cautionary tale of looking at a very small portion of the data and not fully understanding the full picture. And I think it's very relevant to what we're talking about here. So here we go.
Distance 3 nautical miles. Engines throttling up 3 inches.
On January 28, 1986, 73 seconds after it launched, the Space Shuttle Challenger suffered a catastrophic failure and exploded, killing all 7 crew members aboard. This was one of the worst events to befall the space program, and the loss of life was absolutely tragic. Unsurprisingly, a massive investigation was undertaken to understand what went wrong. This Rogers Commission concluded that the disaster was a result of unusually cold weather on the day of the launch that resulted in a set of O-rings failing to seal the solid rocket boosters, which resulted in significant aerodynamic destabilization and ultimate explosion. But the report went on further to conclude that one of the most telling failures wasn't one of engineering, but rather the poor use and understanding of statistics. Welcome to Data Demystified. I'm Jeff Gallick, and in this episode, I'm going to show you how a failure in statistical reasoning by some of the smartest scientists and engineers in the world led to the tragic Challenger disaster. In particular, we're going to focus on how selective use of data can dramatically influence the conclusions we might draw. So let's jump in and see what went so tragically wrong. The night before the launch, the engineers at ICAO, the company that made the solid rocket boosters that ultimately failed, and the engineers and scientists at NASA had a prolonged meeting where they discussed the risk that the O-rings have of failing at low temperatures, since the upcoming launch day was going to be around 39 degrees Fahrenheit, the coldest temperature for a launch to that date. In that meeting, this chart was used to make the claim that the temperature really has no effect on how likely O-rings are to fail. I'm going to recreate this chart and make it a bit nicer to look at so that we can see how that conclusion was formed. Each of those dots represents previous launches where an O-ring had failed in some capacity. Not enough to destroy the space shuttle, but enough to take note. On the horizontal axis is the temperature the day the launch took place, and on the vertical axis is the count of the number of failure incidents for that particular launch. What the engineers did was try and compare the temperature on previous launch days to the likelihood of O-ring failures. And what they did was say something like, look, sometimes it's hot and sometimes it's cold. O-rings fail roughly equally at all temperatures. In other words, just because the Challenger will launch on a cold day doesn't increase the risk of O-ring failure any more than if it launched on a warm day. But can you spot the problem? Can you see what the engineers did so tragically wrong? Well, there are actually 2 things. First, note that the coldest day that they have data for was January 1st, 1985, when it was 53 degrees Fahrenheit. The upcoming launch was going to be 14 degrees colder, well outside the range for which there was safety data. The first problem is that when building a statistical model, which this is a very simple example of, that model is only as good as the data you put into it. If the model is calibrated on data that only include a small range of possible inputs, a limited range of temperatures in this example, that model is virtually useless in making predictions for anything outside of that range. It is unreasonable to draw conclusions about the safety of launching the shuttle when it's 39 degrees outside based on the available data. This was the first of 2 major errors in statistical reasoning that led to this disaster. Again, coming back to this graph, what's critical to point out is that these data only include the failures. As in, this is plotting the relationship between failures and temperature, and not all launches and temperature. When we instead include all launches, we get a very different picture of how temperature and failure are related. Of the 23 shuttle launches prior to this disaster, 16 of them had absolutely no issues when it comes to O-rings. and in all of those cases, the launches took place on days where the temperature was relatively high. To be sure, there were a few higher temperature launches that also had some form of O-ring failures, but of the 7 launches that had a failure, most occurred during low temperature launches. In other words, when looking at all the data, launches that had any kind of O-ring failures and launches with no O-ring failures, the data tell a very different story about the relationship between temperature and failure rates. In fact, the correct story, is that temperature does appear to influence the rate of O-ring failures. The colder it is, the more failure there seems to be. As another example to make this type of error crystal clear, consider the following example of student grades from a European school. This chart shows the relationship between how many days a student misses classes and their grade on a 20-point scale. Looking only at student who missed classes at all, there really doesn't appear to be any kind of relationship here. You might then conclude that missing classes doesn't make a big difference in terms of what grade students earn. But if I instead also include all the students who missed no classes at all, you see a very different picture. The students who missed no classes did, on average, much better than those who missed any classes at all. In other words, there is a relationship between missing classes and success. It's just that the difference exists among students who have perfect attendance and those who miss any amount of class time at all. By ignoring that group of diligent students, we falsely conclude that absenteeism has no effect on grades when it clearly does. This is just like the Challenger data, where we ignore the launches with no failure and conclude, based on just some of the data, that temperature has no bearing on whether O-rings fail or not. Had the engineers looked at the totality of the data, they likely would have come to a very different conclusion about the safety of the Challenger mission. They might have chosen to delay the launch to wait for warmer weather. And this type of error happens in many places. Imagine if a factory only evaluated what caused product defects by just looking at the defective products and failing to look at the conditions that resulted in products having no defects. The point is that when considering the relationship between variables of any kind, it is critical to consider all the data in question and not just a subsample. Doing anything less can result in false conclusions, and in the tragic case of the Challenger, death. Finally, as always, thanks so much for watching.
Right, so it's quite an interesting case there where by not looking at the complete data set or not, again, not turning that data into useful information because there was something missing, then it led them to the wrong conclusion. In fact, it's been that scenario has been used as a sort of test case, and the majority taking it out of putting it in a different context, and almost everybody that sees it says it's okay to carry on, it's okay to go. So it's quite a powerful example. He also talked about at the end there with the tool design, the engineering example, not just looking at when things go wrong, but when looking at things go right, which is something that we are doing in aviation now, which is and learning from all operations. So chapter 7 talks about the use of analysis results for decision making. Yeah, so the link between analysis and the decision, you need to be looking at the right thing, and you need to be communicating it in the right way. And so I'm sure you've got lots of visualization tools to be able to do that, business intelligence tools to create that visualization. But that is a particularly, it sounds fairly straightforward, but actually getting it right is quite a skill. There is quite a bit of information out there on how to do it well. Yeah, that should give a level of insight so that you can see the story in the data. That's the idea of it, so that it's relatively easy to understand what the message is that the data is actually telling you. So one of the things that those engineers didn't have in the Challenger disaster is they didn't really have any kind of structured way of analyzing data and producing it. The meeting was called together at the very last moment, the day before the launch, and they were scrabbling around trying to. Back in those days, they were faxing charts backwards and forwards because they didn't have the internet back then. But they just didn't have a process of collecting the data and collating it, and the kind of thing that we're talking about here to turn it into useful information. And as a result, the communication and the implementation went wrong. So that's what they're talking about here, is having a structured process where you collect and analyze that data, and then you communicate it and visualize it in a way that's useful to the people that need to make those decisions. And this is Scott Berinato talking about how to do that.
Storytelling with data. Everybody's doing it, right? You're not doing it. You should be doing it. You've been told you should be doing it. Storytelling with data is the big thing. Well, it turns out you should be doing storytelling with data, but it's a lot easier than you probably think it is. Once you know the 3 elements of a story: setup, conflict, resolution, you can start telling stories with your data. Setup, conflict, resolution. Every story ever told from the beginning of time follows this structure. It's really that simple. Setup: Charlie Brown runs toward the ball. Conflict: Lucy takes the ball away at the last second. Resolution: And a setup is just some reality. And by reality, we just mean a situation. It could be fictional, but it's a reality you've created for the story. And then you have conflict, which has changed that reality. Without change, there is no story. You just have a bored audience. The resolution is just the new reality that the change creates. So with that in place, we can now take a chart. We're going to break it down, pull it apart, find the stories in it, find the setups, the conflicts, the resolutions. And we're going to rebuild it as a storytelling device. Okay, now we're back with a chart. This is Global Real Home Price Index. The index is 100, and you see a bunch of lines for countries. There's a gray line in there, that's the aggregate as well. This chart is really showing home prices in a lot of different places in the world, and that's where I'm starting. So I want to find the stories in here. The first thing I start to notice really are a couple of things. I obviously noticed that big hump on the green line there, that's Japan, and I noticed that point where everything comes together. To me, that immediately says those are probably 2 places where there's conflict. But I realized something as I'm looking at this, and I'm glad I did, because otherwise I would have had the wrong story, and that is that these home prices are indexed to 2005. So the fact they come together there at 2005 doesn't mean the prices came together. That just means those are the dollars that the people who made the chart used to show the change in house prices over time. So there's really no conflict there, and in fact, I think that's my setup. That's where we start, because that's where they started. I can still tell those 2 stories on the left and on the right, but I start there instead of at the beginning of the chart. I can look backward and say, home prices rose steadily in most places in the world for 30 years, except for in Japan, which experienced a 3-decade-long bubble. And that is a perfectly good story. The setup is home prices rose steadily in most places, except in Japan, which is the conflict, and the resolution, it experienced this 30-year bubble. And then working from 2005 to the right, I have another story, which is that there was a smaller housing price bubble, in most places except Japan. So now the story is flipped. But something different happened this time, and that is that the markets bifurcated. And you ended up with 3 markets, Australia, Canada, New Zealand, rising again, looking much like a bubble, and the rest falling and then rising back to about 2005 levels. So I've really started to see a couple of stories emerge here. One, both starting in 2005, because that's where our prices start, and one sort of working backward in time and one working forward in time. Okay, so I'm going to spare you most of my sketching because it's so messy and chaotic it probably would just give you a headache, but I did a bunch of sketching and I arrived at these final charts, and I've split the chart up into a couple of states. It really helps your audience focus. So here's my setup. You can see it. Prices rose steadily in most places in the world. I try to use my titles to actually reflect the story, and here the steady increase reflects that setup instead of just using a generic title about global real home prices, which is boring and not helpful. The title can really do some work for me here. And then I want to add the conflict and resolution state 2. There it is. You can see we've added Japan, except in Japan, in the title. And that conflict and resolution becomes clear that Japan was this bubble that lasted 30 years that was different than everywhere else. And you can see as I present this, it almost looks seamless, as if I'm just showing you one chart that changes state. So and then I'm just going to repeat this process for going forward. And you see here, I've included my setup, conflict, and resolution all together in one state. You see that little bubble, and then you see the bifurcation of the market. But the most important thing is I've really highlighted the elements of the story in both cases and nothing else. I've left out any information that might distract from telling that story. I've not focused on anything that doesn't matter, to telling that simple story of setup, conflict, and resolution. Narrative is the most powerful, most human tool we have to communicate. If you can apply storytelling to your data, it creates an emotional connection with the audience. They're not only going to believe what you show them, they're going to feel it.
Yeah, so that's very important, that to be able to tell a story, to be able to make your case, and to make that emotional connection is also important. As humans, we are emotional, and we also have some preset beliefs as well. And so just having the data, just having the information, just having the intelligence won't always necessarily mean that everyone's going to be convinced. It has to be put into a format that people are going to understand and get. And stories are the most powerful way of doing that. And if you can tell a visual story with your data, then you're definitely on the right track.
Telling with data. Everybody's
Go to the next slide.
telling with data.
No, thank you. Safety dashboards and reporting, and this is it's kind of interesting. So, if you probably already have dashboards, so you can put your data sets into dashboards, and there's lots of tools around to help you do this. And those dashboards can have a particular theme where you cover various aspects of it. One of the ways that you can also contextualize the data is normalization, and usually normalization is normally done, the industry standard is kind of like events per 1,000 sectors, which is a little bit of context for those events. But you have to be careful with normalization, because if you're talking about, let's say you're talking about cabin crew injuries, well, sectors could be long sectors or short sectors. So sectors doesn't really describe their exposure to the risk, which is when they're at work in the cabin. So you probably need to do hours on duty for that one. Or if you're looking at maintenance error, again, per 1,000 flights doesn't really describe the exposure to the maintenance input that could result in an error. So you'd probably want to normalize that by maintenance input. So normalization is a good tool, be careful of it. Unstable approaches I put down here as an example. So we're talking about getting contextual information. Unstable approaches can have lots of context. So let's say you had a graph on there. It said last month you had 5 unstable approaches. What exactly does that mean? There's no context to it. When you start applying context according to the principles of this document, you could say, oh, well, actually, they were all stable by, the stabilization gate is 1,000 feet, and they were all stable at 800 feet, and the weather was okay on every occasion. So now you've got some context around it. Actually, they weren't unstable approaches to touchdown. They were late stabilizations, and they were stable by 100 feet, 800 feet. Now you could say, why were they unstable at 1,000 feet? Was it configuration? Was it speed? Was it rate of descent? Were they not on the profile? So there's a whole variety of factors you could put there. And if you start, that contextual information is super important. So you could have an entire dashboard just for unstable approaches, one saying we had 5, and then you could have a graph on saying the ones that went through the gate that weren't configured, and the ones that were stabilized late but above 500 feet, and the ones that were unstable to touchdown, and the ones that were too fast. And so the contextual information could very easily create its own dashboard just for one single event. Now, how you manage that is up to you. Maybe you just stick one graph in there, but you do the contextual information to turn that into safety intelligence, and then you use that as part of your briefing pack, or you do a dashboard with all the different potential contexts that relate to your unstable approaches. Role of human expertise. I think this is absolutely crucial to get that judgment. You have to bear in mind that we all have biases as well, and we have to kind of be aware of those when we're applying our expertise. But that insight from people that actually do the work is absolutely essential. If you just believe the numbers, then you won't resolve the ambiguities. So I think you need to integrate people with the data. And I put the post office logo there because, in case you're not familiar with this, they introduced a new software system into the thousands of post offices they have around the country. And all of a sudden, this software said that 10% of their post office managers were actually stealing money. And they went, okay, we believe it. And they took them to court without any kind of other contextual input into that decision. And of course, it turned into a complete disaster because it was the problem with the software. And that's what I mean about back at the beginning there. And in this book, it does talk about automated data collection is reliable. I would say you have to have that questioning mindset about that as well as you do about any other form of data collection. So, yes, there are challenges. If you're introducing this whole system to start with, of course, with any change, there's going to be questions and there's going to be resistance, which you have to persuade and encourage people to get their buy-in to adopt it. The whole concept of analyzing data means you could overdo it, overthink it, and finding that balance between getting the right mixture of data and being able to tell the right story is important, and not to end up with what's it called, paralysis by analysis. And of course, you've got feedback loops in your safety system, so it's going to hopefully tell you that this was a correct analysis and a correct intervention, and it's all working well, and also tell you perhaps when you didn't get it so right, and you can learn from that to help improve your system as well. So chapter 8 is sharing and exchange of safety information and intelligence. I don't want to spend too much time on this. The chapter goes into how to set it up. You might want to set it up. Maybe you're in a group of airlines and you might want to set it up across your group. But it's probably the kind of thing that you might want to join. And it is very, very useful because the number of safety events these days are quite few. And sometimes when you put your data in context with everyone else's data, you can see that actually this is happening across the industry and there's a systemic issue that needs to be fixed. But it actually only happens a few times to individual operators. So for them, it's not really seen as a big issue. The incorrect surface lineup example that I've given there was a few years ago. There was a very high profile low go around from an approach towards a taxiway at an American airport where there was maintenance on the main runway, and so the parallel runways at night could easily be confused for the one remaining serviceable runway in the taxiway. And as a result of that, we looked at the IATA data and we found that actually this was happening somewhere in the world. It was probably happening every 2 or 3 weeks, but without, it wasn't not such high profile event. And then when we got the operators in the room for the sort of safety exchange meeting, it was remarkable that they said, yeah, we've had one of those, but we just thought it was just a one-off. But when they'd all had one of them. So that pooling of data and information into a data sharing arrangement can bring additional context, the context of the fact that you've got everybody else saying, yeah, we've had one of those, and there's something that as an industry we need to address. And again, this is if you're going to set one up, you're going to need all of this stuff, and it's all detailed in the chapter. If you want to set up some kind of data sharing arrangement, then there's lots of references in that chapter to help you do it. And I think it's worthwhile. It's definitely worthwhile. as I said in the example I gave, there are definite benefits to being able to do it. And these are the ones available that I know about. There's GADAM, which is the IATA one. You can contact them at gadm@iata.org. You don't have to be an IATA member. You don't have to pay. The deal is you give your data, they'll give you the access to the websites where you can see the analysis of all that amalgamated data. It can allow you to see trends on issues that you're not experienced much of. It could allow you to look at what the issues are at particular airports. If you're planning to go to a new airport, it can be very useful to you. It's free to join. You just give and you get back, and you can send in your manually reported safety reports, and you can send in your flight data as well. So that's the IATA one. EASA, of course, have got data for safety, which is being developed at the moment. And then the US airlines have a SIAS, which is the FAA's equivalent as well. So there's three that are available that you could be available for you to join. And the last thing in the book is an Appendix A, which is a code of conduct for the standards that you should apply when you're collecting all of this data. And again, it's really a reference section, so I'm not going to read that out. But there's some key principles there of trust and transparency, compliance with standards, using data responsibly, and then the risk, of course, with all of this is it gets misused. That reduces trust, and you end up in a cycle where you end up with less data being shared with you if nobody trusts your system. So that chapter's there, more or less it's a reference, that appendix. So I just want to leave you with one thought, and we touched on it earlier, a little bit of when Scott was talking about build a story with your data to connect with people emotionally and persuade them that this data is telling a real story, that's something we need to do about it. Is along those lines, this is also around how sometimes just having the facts isn't enough to persuade people to change.
A few years ago, I was doing quite a lot of work on vaccine skepticism. Oh, yeah. And working with people who were hesitant about the COVID vaccine. Now, I have to be a tiny bit careful about what I say about this, because what I will say is they are a vocal community. Mm-hmm. They are not afraid to tell me what they think. Yeah. I'm just going to tread delicately and carefully. I also made lots of mistakes in the way that the whole thing was approached. But the thing that I noticed is, well, twofold, actually. One is that the only way that people make decisions is in an emotional way. It may be that you and I, who are scientifically minded, believe that we make decisions based on statistics, but ultimately for us, that is still an emotional story. We have an emotional relationship to data and mathematics and science in a whole story of our lives that kind of builds up to that moment. And it's still an emotional decision. It's just a slightly different one. I think people are not persuaded by data and numbers. I think it is always fundamentally about the social aspect, exactly as you described, right? Because if it was about data, then you could show somebody the right piece of data. You could show somebody the right combination of words, and it would change their mind. And people do not work like that. That's not how it works at all. That's not how it works. And the second thing that's called to mind here in what you're describing is there's something which is called the deficit model of public communication. Okay. I haven't heard about this. Okay, so when you work in an academic institution, there's a lot of talk about how do you get the scientific ideas out to the public, right? How do you talk to people about this? Especially when you look at situations where people are making choices that are maybe counter to their health or maybe counter to public health more generally. How do we get the information out there so that people make better choices, make choices that align more carefully with what's right for them and what's right, overall. And for a long time, people thought that all you needed to do was just give them information, that if you educated people to the correct level, that if you put information out there, then that would be enough. But the problem with that idea is that it's called the deficit model, because it's essentially saying that the only problem is that the public have a deficit of knowledge, right?
They just need the facts.
They just need the facts. And it is the most arrogant, insulting way to, I think, belittle people and to basically imagine that the only reason why somebody is not making the same decisions as you are is nothing to do with their worldview. It's nothing to do with their own version of reasoning, the things that are important to them. It's just because they don't know as much as you do, right?
Right.
And not only is it incredibly insulting, it also demonstratively does not work. You cannot argue or maths your way into changing people's minds or persuading them. It just doesn't work. And I think that the way that you've described all of this stuff, the way that people's logical brains are not geared for statistics and data and abstract descriptions, and the way that our brains are geared towards the social aspect of aligning with other people and collaborating. I mean, just looking at the sort of anti-vax movement against that perspective, it just really, really, really resonates with me.
Yeah, it's kind of frustrating, but it's almost a relief to realize, oh my gosh, you're right. It's not that with the right facts and reasons we'll all agree on something, because that's not what happens.
Right. So yeah, I just wanted to leave you with that sort of cautionary tale there, that we can get all this data together and get the safety intelligence, but we still need the stakeholders to be engaged with us. We still need those relationships with those people. We need to take them on that journey with our data and our safety intelligence, and we need to build the story with them almost, rather than just go to a meeting and put it on a screen in front of them for the first time and they go. It won't, as that case, it's a little bit of an extreme case, but that case kind of demonstrates just having the data and the facts on its own sometimes isn't enough. You need to be mindful of the fact that we are dealing with people, we are emotional beings, and we need sometimes to be taken on that journey and persuaded with what the message is, in spite of the fact that we've done all this work and created this beautiful safety intelligence. So that's all I've got to say. So we'll go to some questions if we've got any. If you're interested in joining the Flight Safety Committee, you can email us there. You can always follow us on LinkedIn as well. And I'll stop.
Yeah, there's one thing just towards the end about data. For the guys who haven't used it, is the SRG 1605 that you can send to the CAA. You can get extracts from their MOR database. I've done it a number of times over the years, and it's especially useful if you're in a smaller organization. But the trick to follow with that is try to specify the data you want using the ICAO taxonomy, because that's how their database is structured. If you're talking about airspace conflicts or drones data, I'd also go to the AirProx board. Oh crikey, I'm trying to think what else. The air navigation people, there's another database called the ABANL, the alleged breach of air navigation legislation. And most airports don't submit MORs, they support into a database called ATR, which is maintained by the National Police Chief Commissioner's board. So we've got all the drones data in 4 different places. But anyway, that's a campaign that we've got on at the moment. In terms of analysing data, trying to cast my mind back to the time of Challenger, and I've got it in my head that NASA was warned by at least one engineer of the potential effect of operating at such a cold temperature, and when we think also to another fairly recent disaster, the Titan submersible, when Stockton Rush basically he skewed the test data to ignore what he was being told. And if you watch the Netflix documentary, it's actually very good. And then he operated under a flag of convenience in order to avoid regulation. He also classes passengers as mission specialists instead of passengers, so he got over that. So data can be skewed to your own end. But the one thing that struck me throughout all of this, through Challenger, through Titan, and various other cases, is that little or no respect was paid to expert knowledge, even though one of the slides did refer to expert knowledge interpretation. So I think we are at risk almost of allowing decisions in safety management systems or operational decisions to be driven by statisticians, not the people who are experts in the fields themselves, not the SMEs. I don't know how everybody feels about that.
Yeah, there's a couple of good points there. I mean, those external data sources are very useful for applying additional context. And to the second point, I think the book does refer about data-driven decisions, and it also forms about data-informed decisions, which I prefer the latter, which implies that the data is going to inform the decision, but the decision involves subject matter expert input.
And sometimes the data just doesn't make sense. And the first slide that he put up before, he normalized the temperature related events for the shuttle launches. The immediate thing was, well, and if 90% of your days are warm and only 10% had that lowest temperature event, which was 3 out of 9, so that's 33%. On 10% of the days, that means your recurrence rate is 3 times higher. Well, it's higher, it's 10 times higher, so 1,000%. It just didn't make sense. So where was the expert input to that? Because the most junior high school engineer should have been able to spot that.
Yeah, and when they put all the launch data in there, you could clearly see that it was on cold days.
Absolutely.
The majority of the time. But I think your two examples there, I mean, the submersible one, which you described as the person involved wanted to go regardless, and so I think most of the time particularly in aviation, people in most of these cases, we're not talking about stupid people or people that are trying to break the rules like that submersible example, but these are smart people most of the time that have made these decisions that with hindsight we've seen turned out to be wrong. But that means that we could all do that, if you see what I mean. We're all vulnerable to being in that position, and so that's why the whole idea of this is to try and avoid that by getting in as much information, contextual information, and building the picture and getting that subject matter expertise involved too, so that we don't fall into that trap that others have in the past.
Yeah, thank you.
Thanks, Chris. Does anybody else have any points they'd like to make?
Just on things from my previous life and training as an analyst, there was a couple of rules that I think still hold good today with any data, because as has just been said, as Chris has just said, there is danger in data, and the first one is validation of that data. And then when you're doing an analysis, it's getting the question right. If you ask the right questions, then you will get the best out of it. And that's the key. That's the big key. If you ask the wrong questions, you will get bad response every time. And one of the things that currently I've been doing a lot of work with analysis with Copilot AI engines that will take internal and external and bits and pieces, and they're very, very good, but it still comes down to that question: is what are you asking it to do, and making sure that you stipulate how you want it to analyze, which analysis model are you actually going to use. on it. And if you don't stipulate those, then potentially you're going to find yourself in a world of hurt.
Well, yeah, some really good points in that. And then certainly, I think that asking the right question, that's super important, because there's two things there. One, the people that produce, everybody has to be prepared to be challenged and accept that questions are good to try and improve the data and the message it's showing. So you need them to be receptive, as well as you need to position the question and ask the right question of them as well. And even to the extent that if you're in a meeting and someone's presenting a bunch of graphs at you, I think it's a natural tendency. I certainly don't just go, oh yeah, what's that telling me? Rather than actually, should it be showing me something else? Is there something missing that needs to complement that? So that's another thing that we can do, as you said, we can challenge the way it's being presented. And I'm glad you mentioned AI, because this manual, this ICAO manual, doesn't mention it at all. It does mention software, which I suppose generically could be included in that. But I imagine that somebody somewhere is beavering away on version 2, which will bring AI into the loop. And as you mentioned, AI is very interesting, because I've used Copilot and ChatGPT as well, and sometimes it just won't do what I want it to do. So I say to it, what do I need to tell you to make you do this? And it comes back and it tells me what I need to ask it, because I've just been asking it the wrong question. So that's as true as it is for AI as it is for humans, right?
Yeah, and I think that's the point with it, is that if you use an agent, if you create an agent in AI, it will do exactly what you ask it to do. And if you haven't asked it in the right taxonomy, it's not going to give you the result that you wanted. And I think, as I say, the important thing is, and also with if you're doing it manually, is making sure that whichever analysis model you use is geared correctly to the data that you've got, so that you do come out with those right answers, and it will enable you to validate it a lot easier.
Yeah, absolutely, totally agree. Thank you, Chris. Any more comments or questions? No, I think that's all. Nobody else is putting their hand up. There's nothing else in the chat, so I think we can perhaps wind it up then and bring it to a close. I really hope it's been useful. Like I said at the beginning, it's the first time we've done this format, first time we tried a webinar. So feedback would be really great to help us to what you think we did well, what you think we could do better. And if you have time to put something in the chat, that'd be really useful for us. So otherwise, I'm really pleased that so many people came. Thank you for your time. And I do hope that you found it useful in some way. So thanks, everybody, and have a great evening.
Thanks very much, Rob.